Hello and welcome to By Excellence Tutorials. Well, today in this video, we are going to solve a linear momentum and collision problem. All right. The question says, a pool ball air of mass 0.4 kilogram moving with a speed of u being equal to 1.8 meter per second along the positive x-axis strikes another ball B initially at rest of mass 0.5 kilogram. The collision results in ball A being deflected off at an angle of 30 degrees with respect to the positive x-axis with a speed of 1.1 meter per second. Calculate the speed of ball B after collision and the angle the ball deflected. Well, so how do we go about this one? Now, this question, as we can see that it starts from one dimension, all right? It has started from one dimension and now it has gone to two dimensions. The moment we've had something to do with angles, deflecting, it has gone two dimensions. So this is where a lot of students find it difficult when it comes to resolving of the angles, resolving of the velocities or speed. They find it difficult, but guess what? I believe you'll be able to understand. Okay, so let's say we have, let's say this is our axis. All right, so that is our axis. And then we have the first ball A is moving. We are told that it's moving with a speed of 1.8 meter per second. I'm taking my time so let's say this with subscripts A to differentiate, and the mass is 0.4 kg. All right, so it's moving and finds another ball. This ball now is at rest where the velocity is 0 and the mass here is mass of Bobby is 0.5 kilograms. So this is before collision. Now, after collision, what happens is that after collision, we are told to say the first ball deflects 30 degrees with respect to the x-axis. All right, the positive x-axis, 30 degrees. So this moves with, let's say, this is VA, moves with 1.1 meter per second. Now, where has the second ball of ball B gone? So we're going to take it to say, maybe it has gone this direction. And we have the angle theta there, which we don't know. And also the velocity, final velocity, which we also don't know. So what we do first is to resolve these velocities, because we can see that they are in two dimensions now. So we resolve these velocities. So we're going to resolve these velocities. Okay, can I get, is it possible for me to have another color of the pen? All right, so it is possible. So we have like that, okay? And then can I have also another one? Right. Okay. So it's trying to differentiate this. So now, let's see. So what we have is they have both the x and y component. So let's start with the ball A. The A ball has got what? It has got this velocity. Now, resolving it for the x component, we are basically going to have 1.1 cos 30. And the resolving of the y component is basically going to be 1.1 sine 30 or VA sine 30. All right. Now we come to this one. This one we're going to have VB, which we don't know in X, VB cos theta. And in Y, we are going to have VB sine theta. All right. So we have made things easy now. Then we need now to look at the conservation of linear momentum. Now, conservation of linear momentum, in this case, it's in 2 dimensions. So we're going to take the x-axis and also, or the x motion and the also vertical motion separate. So we say conservation of linear momentum, right? So we say in x-axis. So in x-axis, what we have is the first ball has got momentum in x. So we have momentum for the first ball in x. So, okay, so let me say momentum also for the second ball in x should be equal to momentum, final momentum for the, and also like that. All right, so now for the first one, we know momentum is mass times velocity. In x, this first ball was moving in the horizontal. So what we're going to have is mass times the velocity, which is 1.8, plus this one initial velocity is 0, meaning we have no momentum. And here after collision in x, we have that. Mass has not changed, so we're going to have 0.4 times 1.1 cos 30, plus we're going to have also 0.4 times 1.1 sine 30. All right, so we can reduce this one. Oh my goodness. Sorry. So we get the, I've gotten the x and the y component of the same ball. So no. It's supposed to be for the second ball. All right. Don't make such a mistake in the exam. Please don't make that mistake. All right. So what are we going to have? What we're going to have is this one, which is BB cos theta. All right. So we begin to find, so we have 0.4 by 1.8. What we have is 0.72 being equal to here 1.1 30 times 0.4. Sorry. Even here, sorry, we multiply by the mass, which is 0.5 to make momentum like that. All right, we haven't cancelled anything. So we have 0.38, all right, and we have plus 0.5 VB cos theta. So we can take this guy the other side, and we're going to have 0.72 minus 0.38 equal to 0.5. All right, I can even divide by the mass, which is 0.5. All right, so let's have that. And then I'm going to have 0.72 minus 0.38. I have 0.34, 0.5 VB cos theta. So I can divide by 0.5, 0.5. So what I'm going to have is VB cos theta being equal to 0.68. So let that one be my equation 1. So that was in X. Now, you also look at momentum in Y. Now, was the first ball moving in 2 dimensions? No. Was the second ball in 2 dimensions? No. So before collision, momentum is 0 in the Y. And in the Y after collision, we have the first ball, which is 0.4, moving with that component 1.1 sine 30 plus. Now, the second ball, you can see that the speed has gone, it's pointing downwards, all right, which is negative. So what we're going to have is negative VB sine theta. All right. So we know that momentum is a vector quantity. So we need to take direction very serious. So we have this one is going to give us 0.22 minus 0.5 VB sine theta. So I can take this one the other side, and then I'm going to have 0.22 equal to 0.5 VB sine theta. This 0.22, when it goes the other side, it will be negative, and dividing through by negative or multiplying by negative, it will give us positive. So we have 0.5, 0.5. So this one also will give us VB sine theta being equal to 0.44. All right. So that one is also my second equation. So now, having those two equations, I divide equation 2 by equation 1. All right. So what we're going to have is VB sine theta over VB cos theta is equal to 0.44 over 0.68. Right. So VB and VB will go, and here I'm going to have tan theta, sine over cos, you get a tan. All right. So now, what do we have? We have 0.64705. So the angle here going to be 32.905, which is approximately 33 degrees. All right. So we have 33 degrees. And then you can now substitute in any of the equation 1 or equation 2 to find VB. So if we use the equation 2, we have VB sine theta equal to 0.44. So VB equal to 0.44 over sine theta. So VB is basically 0.44 over sine 33. So from 0.81 meter per second. So that is how you get to solve such a linear momentum problem when it comes. All right. I believe happiness is understanding physics, and you did understand as I was explaining. So if you found this video or my channel to be helpful, kindly give me reactions when the videos are uploaded. When you watch a video, give me reactions, like, comment, and you can as well share with others so that they can as well be benefiting from my videos. Thank you so much in advance.